In number 1, we have the limit as x goes to 0 of sine 5x over x. Let's multiply the top and bottom of this limit by 5. So then we have 5 over 5 times sine 5x over x. And we know that the limit as x goes to 0 of sine 5x over 5x, in other words, this part, we're familiar with this limit, and this goes to 1. So this limit must go to 5. In number 2, we have the limit as x goes to 0 of sine 3x over sine 5x. So again, we want to use the fact that sine x over x goes to 1 as x goes to 0. Alright, so we're going to manipulate this limit a little bit. We want to put a 3x underneath the sine 3x because we know that this goes to 1. And we want to put a 5x on top of the denominator sine 5x because we know that this fraction also goes to 1. Okay, so we multiplied top and bottom by x of this original expression. So that's okay, these x's canceled. But we also multiplied the numerator by 5 and the denominator by 3. So we must multiply by the reciprocal, 3 over 5, to cancel that 5 over 3. Alright, so now we have this quotient going to 1, and this quotient also goes to 1. So the limit is 3 over 5. Here we're taking the derivative of a composite function. Let's remember the derivative of cosine is minus sine. So I'm going to start by rewriting this exponent notation using the usual bracket notation instead. Okay, now we're going to use the chain rule, and we'll start with taking the derivative of the outermost function, which is the exponent 6. Just bring that down. And subtract 1 from the exponent, and rewrite what's inside the brackets. Now we're going to multiply by the derivative of the inner function. Remember that the derivative of cosine is minus sine. So here we have minus sine 8x squared plus 5. And now the derivative of 8x squared plus 5, again using the chain rule, is 16x. In number 4, we have a product. Okay, 3x to the 7th times cotangent. So we're going to use the product rule. Alright, so let's start. dy dx is equal to the first, that is 3x to the 7th, times the derivative of cotangent x squared plus 1. Remember, the derivative of cotangent is minus cosecant squared. So we have minus cosecant squared of x squared plus 1. And now again, continuing with the chain rule, the derivative of x squared plus 1 is 2x. So multiply by 2x. Alright, so that's just part of it. That was just the first times the derivative of the second. So we did the first times the derivative of cotangent x squared plus 1, and now we're continuing the product rule, the derivative of the first, that's 21x to the 6th times the second. Here again we're going to do the chain rule, and again I'm going to rewrite using a bracket notation for that exponent. So we have cosecant 5x plus 2, and I'm just putting the exponent outside the bracket. Now I'm ready to start the derivative. Using the chain rule, we're going to bring down the 8. And subtract 1 from the exponent. And now we're multiplying by the derivative of cosecant 5x plus 2. Remember, the derivative of cosecant is minus cosecant cotangent. And now multiplied by the derivative of the inner function of 5x plus 2, so we have a 5 coming out. In number 6 we have a quotient, so we're going to use the quotient rule to find the derivative. So we'll start by squaring the denominator, and then put the denominator up here in the numerator. Multiply by the derivative of the numerator. So first we're going to do the chain rule, bring down that 5. And let's see, let's write 5, I'll use parentheses, 10x to the 4th. Multiply by the derivative of tangent x, again chain rule. And now continuing the quotient rule, we have derivative of the denominator, which is 20x, times the numerator. In number 7 we have a function, and we want to find where the tangent line is horizontal for x values in this range. So first we're going to take the derivative and see where it's equal to 0, because that's where the tangent line is horizontal. Alright, first the first term, x sine x, we'll do a product rule to take the derivative of x sine x. So that's the first x times the derivative of sine x, which is cosine x, plus the derivative of x, which is 1, times sine x. Alright, continue on to the second term. The derivative of cosine x, that's minus sine x. And now the third term, the derivative of minus x squared times the square root of 2 over 4, just the power rule over here, we have 2x times the square root of 2 over 4. And we'll just reduce that. Square root of 2 over 2 times x. And notice here we have sine x and minus sine x, so those cancel. So this dy dx is equal to x cosine x minus square root 2 over 2 times x. Let's factor out that x. And we have cos x minus square root 2 over 2. And we want to see where is this equal to 0. So we want to solve this to find where the tangent line is horizontal. So we're going to set each factor equal to 0. First set x equal to 0, that would be one solution. And then setting the other factor equal to 0, cosine x minus square root 2 over 2 equal to 0, we get cosine x equal to square root of 2 over 2. Now cosine x is equal to square root 2 over 2 for x equal to 45 degrees in the first quadrant. So that would be pi over 4 is 45 degrees. And here we're only talking about x values between minus pi over 8 and pi over 2. So that would be the only value in that range for which cosine is equal to square root 2 over 2. So we have x is equal to pi over 4. So those are two places where the tangent line is horizontal.